So what is cluster analysis, all right? Did you guys think it was useful? Of course, it's very useful. So basically, if you have a bunch of data and you want to explore the data and find out if there are natural groups, and it's so much data you can't just sort of eyeball it, then, well, smart people, I wouldn't say smarter than me, but they've specialized in something different than me, okay? They've come up with algorithms to automatically group these data points, and this group of algorithms are typically called, clustering algorithms. So by using one of these algorithms, you're doing a cluster analysis. Okay. So when is a cluster analysis used? So obviously, like I said, it's when you want to explore the data. So we don't know beforehand who belongs in which group. So can you guys think of any examples, either real world, I always get my tongue mixed up when I say real world. Okay, it's like a tongue twister, yeah, but it's more of a jaw thing. Okay, so can you guys think of any examples where clustering analysis is either used or where it could be used? Now remember, the purpose is to create groups, useful groups, and there's so many applications.
In marketing,
Yeah.
like what group of people they want to market a specific ad, so they want to separate it like into groups, so they have like a group like marketing strategy for that specific page, like that page.
Or by wine preference. I mean, that's exactly the example in the book, so congratulations for doing that. But obviously, wine is one example, but so many marketing examples. Go ahead, Jim.
Probably if you're looking to get demographic information.
Get demographic information?
Separate into certain demographic information.
So let's think about that a little more, okay? So we already know, and we don't need a cluster analysis to say, you're old and you're young, or something like that, or you're poor and you're rich. That's a sort function. So what else can you say? What do you think?
Maybe if you would like in politics or something, you take a survey or a poll, and say, how do people answer that this type of question? How do you agree or disagree with this? Maybe you can infer their political leanings or
Okay, that's good. So bring up something controversial, since you brought up politics. A controversial issue.
climate change.
Okay. So what would you say?
So you can say,
What could your test? What would your test be, or what would your analysis
do
be?
you agree or disagree that, let's say,
The global warming is yeah. That's right.
So people who say yes, you can probably infer that, okay, these people are not skeptics of climate change science. They're probably a little more left-leaning than center. So therefore, maybe they agree with other issues.
Well, you could do that, but I think just even simplifying it further, going back to your demographic point, is you could say these are the characteristics of the people who said, yes, global warming is a man-made phenomena, and there'd be no people who say, no, climate change is just a natural cycle, And you could check out their demographics. And like you said, you could probably infer a lot about a person based on that one question, but you wouldn't be 100% right. But you'd want to do more questions than just that one. More controversial questions. Questions about gun control, climate change. But, an interesting issue now is what's been going on yesterday, right? And what was that, Stephanie?
And what was it, the MSN, which were, there's like people in the Senate against the government having any ability to respond.
Patriot Act expired.
So yeah,
Some sort of hashtag rolling around, it's like stand with the, it's like the senator in Texas.
some random guy.
It's like trying to do this whole campaign against
And so
national security.
So Jim says, on some issues, you can, if you know how someone stands on that issue, maybe you might know how they stand on other issues. But what about this issue? Do you guys know if this is if abolishing the Patriot Act or letting it expire, is that a conservative cause or a liberal cause? To let it expire. So it did expire. The Patriot Act expired. So who supported it more? I mean, liberals or conservatives? Okay, you're assuming that.
The expiration or the
Just what Rand did. Rand let it expire, right? Rand Paul did.
yeah.
One of them. So, yeah, you say liberal because there are conservative, hawks out there like McCain. But of course Obama was completely for renewing the Patriot Act, right? And it seems that in the general populace, this issue is a little murkier. Like, I read Huffington Post, and everyone wants to let it expire. I read a conservative blog, and everyone wants to let it expire. But if you look at our leadership, most people want to renew it in some form or another. So if you try to cluster based on this decision, you might want to add this the support. So you might add this to your questionnaire, whether you support the expiration of the Patriot Act. So you might, instead of having two clusters, you start seeing liberals who want it to expire, liberals who don't want it to expire. So liberals who are libertarian, liberals who are big government, or something like that. I mean, you might get more clusters of people the more issues you add, or you'll get interesting clusters. Anyway, so cluster analysis is there to tell us what are the natural clusters of people, and maybe how many actually exist. Okay. So what can you do with cluster data? So you can recommend films, right? Based on habit or taste. You can design audit plans based on firm characteristics. I threw that in there for you guys. Identify crime hotspots in urban areas. Group return-related financial investments to ensure a diversified portfolio spans clusters. Okay, so I wanted to show you this example. It's pretty cool. So, name an object, random object. Okay. A computer. Well, that's a pencil. That will work well. All right. So let's cluster on a pencil. All right. Let's go to let's just mix it up a little. So I'm going to go to yahoo.com. They use Bing, of course. I'm going to type in pencil. Get images. Hopefully nothing inappropriate. All right. So here's an image of a pencil. A Dixon Ticonderoga. Can I go to the... can I go to the place where this... How do I go to the URL? View source? What? No. How can I go to the Yeah, I know if I use Google. Stupid Yahoo. Yeah. Oh, here's where it's located. Okay. All right. So, hold on. Okay. Open link. There we go. All right. So this is the URL for the pencil. This is where it's located on the internet. All right. I made it through Yahoo. Now let me go back to Google. So images.google.com. And now I can search for things that look like that pencil. And I just click on that little camera. See that? And I paste the URL. And let's see. Visually similar images. Yeah, I'd say those ones look similar. What is this? All right. Now what's funny is you can do things like similar, let's see, type, face. A face that looks like a pencil. Okay. This face doesn't look like a pencil, but there's a pencil in that picture. You can get photos only, clip art, all right, line drawing, animations. Okay, so yesterday I did broccoli. It brought up some interesting faces. A lot of photoshopped heads on broccoli stalks out there. So there's a cluster. Of course, it's Google. Their cluster algorithms are very sophisticated. All right. What's cool though, what you may not have noticed is you can upload your own picture. Okay. So take a picture of a building, upload it, and see if there are other pictures of that same building. Maybe we'll try that one of these days. Oh, really?
Yeah, they do backward searches like that to see if people are lying about their pictures.
Ah. Well, if you can find a clip of that, then maybe we can show it in class. But look for it outside of class. Catfishing. Any of you been catfished? All right. Of course, we know the football player was catfished, so he says. All right. So that's called a reverse image search. All right. So there are different types of cluster analyses. So one is called density-based clustering, and clusters are identified based on the density of the data points, the characteristics of the data. So less dense areas aren't even part of the clusters necessarily. Okay. So in this example, as long as the dense areas continue, I mean, the clusters can take on any shape. And then these gray dots out here would be considered, outside of the cluster, borders between clusters. Another type of clustering is called hierarchical clustering. And there are two ways of conducting a hierarchical analysis. You can either say everything starts in one cluster and then it starts dividing itself up. And you can actually represent a hierarchical analysis using a dendrogram, like a tree diagram. So another way is to say every item is an individual cluster. I mean, every item's their own cluster. And then you just start combining clusters until you want to stop. Okay. So in this example, every item is an individual cluster. So here's the dendrogram. So you can say, let's see, A isn't really close to anything. But if you went to level 2, you might combine B and C and D and E because they're really close. So in this case, if you stopped here, A would be a cluster, B and C would be a cluster, D and E would be a cluster, and F would be a cluster. But if you go to the next level, they combine F with D and E. One level down, they combine all 5 of the letters at the bottom. And if you want, just make one big cluster and combine A with the other clusters. So it seems like in this example, there are one way to cluster these data points would be to create 3 clusters, B and C, D, E, and F, and A by itself. Or maybe you would consider all these at the bottom of a cluster and A its own cluster. I don't know. Okay? So it depends on the rules you set. So there's something called distribution-based clustering. So clusters are defined as objects belonging most likely to the same distribution. Okay. So one prominent method is known as Gaussian mixture models used on data sets with Gaussian distributions. So what's a Gaussian distribution? It's a normal distribution. Okay. So towards the center of the cluster, it's very dense, and then it normally or evenly spreads out towards the edges. Okay, so if you have that type of distribution of data, then you might want to use a cluster analysis that's based on Gaussian data sets, Gaussian distributions. So here we have the green, so it looks like a normal distribution. Everything's heavily centered and then spreads out. The red and the blue are the same. But it would be more rare to find data in this format. So it'd be more rare to use this type of clustering method. Then there is centroid-based clustering. So in this case, the data points are assigned to the nearest cluster center. And the number of cluster centers is typically assigned by the researcher or the analyst. So in this example, we have, you can see a cluster center here. It's just a little circle. The one here is obscured, and there's one here. And every data point is assigned to the nearest cluster, okay? So does it matter what type of cluster analysis you use? Yes. So if you have data that you know is going to be more density-based, where you want to find, and I don't have a concrete example for you, but where the shape of the cluster wouldn't matter, for example, then you'd want to use a density-based function. And if you have data where there are groups that are siloed, then a centroid-based clustering method would work better. So do you guys recall which type of clustering the book used in the example? Yes, of course you do. It was a centroid clustering method. They used k-means clustering. So how does k-means clustering work? Well, first, what it does is it takes some data points and puts them into k-number groups. And each group is defined by some point in the center. And what the algorithm does is it minimizes the average distance between data and their assigned centroid. So let's go through the example in the book. Now, how many of you actually went to a middle school dance? And this is what happened. Like, the boys were on one side and the girls were on the other side. And maybe the chaperones were chatting with themselves. Yeah? Okay. So you're a brave guy, right? Did you break the ice? Did you start everyone going?
I think so.
You did. I bet you did. I know. Okay. So what's the best way to divide people on the dance floor into clusters? Well, let's say that we think there are 3 clusters in this data set. What the author does is he says, okay, we'll just put one in the middle and one in each corner. Those are the centroids. Now, we have to figure out who's closest to the middle, who's closest here, and who's closest to that centroid. All right. Well, turns out that if you use this method, no one is assigned to this cluster. About 3/4 of the people are assigned to the middle cluster, and you have 4 people assigned to the outside cluster. Okay? Doesn't seem right, does it? What the k-means algorithm will do is it's fine. You start out with the centroids here. But what the k-means algorithm does is it moves the centroids around. And that's what you guys weren't able to observe, because when you use the solver program, that's what it was doing. It was moving the centroids around and finding the place where the distance from the data points to the centroid, the average distance from the data to the centroids was minimized. And it's actually an NP-hard problem. So in my operations research class, we looked at different difficulties or hardness of problems. So NP-hard means, I'm not exactly primed on this topic right now, but NP-hard means it's very difficult and it takes a ton of computing power, or maybe it means it's even, there are intractable problems. I don't know if NP-hard is intractable. That means it's impossible to find the optimum solution, okay? But you can get pretty close. So this is an NP-hard problem, which means your solver might find a slightly different solution than someone else's solver, okay? Because you can't go through all the different possibilities. There's just too many. Okay. So here, the centroids are moved around, and we have slightly better results. Okay. So using solver, we would get some sort of solution like this, or where the centroids are placed right in the middle of the 3 groups. And of course, he mentions in the book that, hey, once we found these clusters, we realized that cluster 1 was all young males, cluster 2 was all young females, cluster 3 were old people, the chaperones. Okay? A typical middle school dance. So this, what he says and mentions in the book, is this is a toy problem. Okay, and toy problems are so useful. So whenever you're toy problems I don't call them toy problems, but the idea is taking a difficult problem and creating the simplest version possible. Okay, the simplest version that maybe you can eyeball the solution. You can figure out how it works, and then from there you can get more complex. So this is an idea that's true with programming. So when you guys are programming and trying to come up with a sweet user interface for your organization that you're going to send your spreadsheet to, you start with something really simple, okay, like I did, like with the buttons on the form, and you make the form pop up. You're like, yeah, that looks neat, doesn't look professional, but I've got the bare minimum working. Now I'm going to make it do something else. Okay. So in programming and in data analytics, always reduce the problem to something that's just, it's very simple, solve it, and then move on to something that's a little more difficult. Okay, it's a great strategy. And so in this problem, he just showed 2-dimensional space, right? There were people on a dance floor, X, Y coordinates, easy to cluster based on that. So he poses the question, what about a situation where there are thousands of products sold and customers must be clustered based on past purchases within this product space, okay? So all of a sudden, you can't define me as a customer as someone who's, say there's two products. You know, I bought product one, I didn't buy product two. You could actually represent that on a graph, okay? X and Y. One's X, one's Y. And you could put me there on the graph. But if there are 1,000 dimensions where I either have purchased or haven't purchased each of those products, then you can't represent that in 2D space. You can't visually eyeball the solution, right? It's actually a high dimensionality problem. So this is a solution that we can't eyeball, okay? You know, if you're trying to group me with different customers of the same store. So he gives us an example that's more complex, and I like that it takes place in New Jersey. That's not why I had you buy the book, but I thought that was great. But I don't like that he calls it Joey Bag of Donuts Wholesale Wine Emporium. That's kind of insulting to New Jerseyans. Like everyone's a gangster named Joey who eats donuts and sells wine. Okay, so it's a little bit frustrating, but at least it's in New Jersey. So why don't you guys describe to me the problem of this case? Okay. What's going on? What's the situation? Yeah, Ahmed.
Joey sells wine at a discount, but he sells it by a case or by a case. And he has a lot of, yeah, he has different offers throughout the year. So he might have 2 in January, 4 in April, and so on. And he just wants to see the trend in the sales by his customers.
So who are Joey's customers?
Individuals that,
So he actually sells to retail stores. So he's actually like the wholesaler or something. Not the wholesaler, but he's like a middleman. So he buys wine from across the world, then he sells, you know, crates and crates of wine to.
all his customers were individuals. They weren't wholesale retailers.
Oh.
Wasn't store.
You're right. Maybe, yeah, wasn't they were stores though, right? Maybe they were. Maybe it was the name of the contact. But I don't think I think it was selling to other stores, right? Yeah. I know you're right about the names of the customers are. Let me just get this right, just because it'd bother me if I'm telling you the wrong thing. It's select wine. It's selling to select wine and liquor stores. Yeah, but you're right. The names of the customers are like Adams, Allen, Anderson, Bailey. They're names of people. So let's just assume that's the contact, his contact within some company, or the name of the I don't know, the name of the owner. I don't know. Yeah. Anyway, it doesn't even matter really who the buyer is, but since he's selling so much wine, it makes sense that it's a store. So you're right. So you said he has different deals throughout the year, and with he sends a newsletter out, right, by email, and it's working very well for him. But what?
But he wants to target specifically the products to the customers that are interested. So he doesn't want to like spam everyone. So he wants to target the people that want, for example, champagne instead of just wine.
Yeah.
So they wanted to cluster it into 4 different. The first part was 4 different clusters.
Yeah. Right. Okay. So what else? Yeah, Ashley.
Newsletter to be so the first thing on the newsletter when they open it is what they're looking for. And then maybe they'll want to buy the others, but at least they see exactly what they want and then
Mm-hmm.
the deal. And wants to see like how often they actually buy that product to see like what it is that they truly want.
Mm-hmm. And that, I mean, that's what he uses for the clustering data, right?
Yeah.
Yeah. But what you said before was, yeah, something that he's not going to not offer the deals to everyone, but for those customers who fit a certain cluster, they'll get a special email where the things they're interested in are at the top and maybe in the subject line. Their subject line might change, okay? So instead of just email blasting everyone, different groups will get emails that are tailored to them to hopefully boost sales even higher. Okay? So what did he do? Let me see. So what kind of data do we have to work with? I know we got everything. Let me zoom in, magnify. So, okay. Okay, so here's the data on the offers. So what we need to do is we need to understand the data. Remember? So who wants to describe each of these columns for me? Ashley?
So the campaigns, the amount that we sent out to each newsletter. The next one would be what it is that I think the person purchased. So they purchased champagne or whatever the case is, and then I don't know, is that the one that they?
So I think the column, actually I think I need to move over. Where's column A? Oh, there we go. Offer numbers.
And then that, I think C is what he's offering and the minimum that you have to buy.
Yeah, that's right.
Discount rate that you would get at, where it's coming from, and if it's past peak or not.
Okay. So it's not what people, I know you said at first it's not what people bought yet, but this is just the offer, okay? All right, so these are all the different offers. There are like 30 or so. How many were there? 32. Okay. All right, now Mark, do you want to describe this complex table?
Yeah, that would be the customer's last name and the number of the offer that they purchased.
That's right. Now, what could the author have, or the data smart author, what could he have added to this? I mean,
Could have put like the whatever type of wine that they ordered to make it like simpler, so you don't have to like keep back checking between offer type and then the wine.
well, I mean, you could you could add that yourself. I mean, that information's there, but what information? Because offer 2 corresponds to a certain type of wine, right? Yeah. I mean, the information's there. He could have put it here in this table, but what I mean is there any missing data? I mean, yeah, quantity. That's what I was thinking too. Quantity. Yanni? Oh, the total amount. Yeah. Now, Vianney, you're really opening up today. I really like that. So let's keep that. Are you presenting on Wednesday? You didn't volunteer to present first day? Doesn't surprise me. I know you want more time to prepare. Okay. Anyone else? I'm not sure there's much else to put there, but anyway, it simplifies the problem since all we know is whether they bought the offer or not. So in order to do the cluster analysis, what form did the data have to be in? A matrix. So what do you mean by that? Do you mean, yeah, he did the pivot table, right? And what, before we look at the pivot table, I mean, you have to know that you need a pivot table. But how does the data have to be structured? I mean, just describe.
The offers that he made, people that bought.
And not only the people that, whether you bought anything in that offer, but also if you didn't buy anything in that offer. In fact, most of the table is full of zeros. Yeah. So he used a pivot table. I have to admit, I'm not great with pivot tables. And that's one area where I can really improve. So using the pivot table, he's able to show everyone who purchased offer 1, offer 2, offer 3, and so on. Okay? And then you can just copy and paste this matrix that you generate and put it into a regular spreadsheet. And that's what he did here in this tab called matrix. Okay? So now what can we tell from this data that we couldn't tell before? This is the same as the so this is the offer information table, right? And this is basically the transaction table, but in more detail. Instead of saying we already knew everyone who bought each offer, but now we know everyone who didn't buy each offer. And it's in a matrix. All right, guys. So in order to continue this discussion, we need to go over some major concepts, okay? And these were described in the book. I'm going to need you guys' help. So I'm going to make some assignments, okay? Then after lunch, you guys are going to work on this, and you're going to discover the use, depending on which one of these you're looking at, you're going to discover its use within the chapter.